A slightly different learning live stream for me today. It's not actually live because we couldn't really get the software to work. I usually just use Open Broadcast Studio, and we tried something else and it just wouldn't work. I have no idea why. What is Learning Livestream? Well, every week, a couple of times a week, normally, I take a look at a software project or some kind of technique or tool that interests me, and I go live with it, trying to figure out how to get it to work. This isn't live, but it's recorded live. There's going to be no editing here. I'm going to be looking at Fermyon, which is a WebAssembly platform. Let's dig into a bit more detail about that in a moment. And I have actually covered them on the podcast before, and I've been meaning to do a learning live stream for a while. And actually, the company said, would you like a guest? I thought, why not? Let's do it. So I will now, and here is where I have to figure out how this is going to work. There we go. Mikkel from Fermyon. Maybe you would like to explain what Fermyon is at a very top level. This is learning live stream, not a marketing pitch. So at a very top level, what is Fermyon?
Thanks, Chris, and thanks for having me here. I'm really glad you gave us the opportunity. So first of all, Fermyon is a company, and Fermyon is the company behind an open source project called Spin, which is about developing serverless applications and microservices applications by using WebAssembly.
Okay.
So there's a few projects we built at the company where Spin is one of them. Another one is called Fermyon Platform, and a third one is called Bartholomew. But all of those are things that sort of revolve around this idea of building serverless applications using Spin.
Yeah. Okay. And how long has the company been around for? I think when I was speaking with Matt, we discovered we both came from Drupal backgrounds back in the day.
Oh.
But just very quickly from your perspective, how long has it been around, and what is the actual problem that Fermyon is trying to solve?
So the company's been around for a year and a half, a bit more than a year and a half now.
Okay.
And both Spin and Fermyon Platform and those other projects has been around for just a bit more than a year.
Oh wow!
So things
pretty fresh.
Things are still very new.
Okay.
In short, we're just here to fix serverless. That's the mission that we are on.
Many would argue that serverless is a problem that doesn't need fixing because we don't need serverless, but we'll go. That's a wider conversation we won't go into here.
Yeah. But I mean, expanding a little bit on what I mean when I say fixing serverless, and to give you some background history on this, is that the team behind Fermyon discovered WebAssembly as this emerging technology, and in very specifically, we talk about server-side WebAssembly, or the specification called WebAssembly System Interface. That enables you to write WebAssembly applications that run outside of the browser. Now, WebAssembly has this history of being developed for in-browser experiences, and how you would be able to bring other programming languages and JavaScript to the browser. But the WASI specification then takes that outside of the browser, so you can create these virtual machines that can run WebAssembly modules. It's the same base specification, but a different set of APIs that you interact with.
Okay.
So from that technology and investigating that technology, a lot of great vision sort of emerged around that. In particular, because the team had been working in the container ecosystem for many years. Part of this team has been, heavily involved in Kubernetes. The team did the Helm project and those things. So there were a lot of those problems that, we saw in that ecosystem of containers, where we thought of WebAssembly, or WASI specifically, as a technology that could take this, solve up some of those problems that we've seen in that space.
Okay. All right. I think there's some other conversations we can have along the way. I'm gonna
definitely
just sort of dive in. This is the Fermyon website, fermyon.dev. One of the things, actually now, first, I think I may be on the wrong website. I think you have two websites, don't you? So I should clarify that.
Yeah, I mean, so Fermyon.com is the company website.
Yeah,
We have the main documentation website you probably want to get to is developerfermyon.com.
Yeah. So I think I will probably start with the open source project first. That's how I usually look at these things. So I'm just going to go right to get started, or if I want to do the open source, should I not? I don't usually ask these sorts of questions, but I have someone to ask. So is this what I want?
That will take you to the open source project. Yeah.
All right. Oh, there we go. Oh, hello. A lot of windows just opened. Okay. But I'm being asked to log into a cloud now. Is that what you expect?
Yeah, so just to make sure we know how these things line up, Spin is the application framework that will actually produce our WebAssembly based applications, the serverless applications. Then for hosting options for running those applications, you can definitely use Spin itself as just a CLI tool to run them. Then we have the Fermyon platform that we released a while back. That is a stack, of technologies using Nomad and other things that can enable you to build a platform to run many applications in and have scaling options and things like that. And then what you see here is, sorry.
Yeah, I think I'll try locally for now.
Yeah, that's a good place to start.
So I probably want to go back to the dev site, I guess.
Yes.
Yeah? Okay. All right.
Well, I think the easiest one is from the website here. You go to under projects, and you should be able to go to Spin.
For some reason, I don't think. Oh, there we go. Oh, yes. I remember Bartholomew as well, because this is what I was talking about with Matt, because we came from the Drupal background. All right. Yeah. Okay. Now this. Okay. There we go. All right. Cool. Okay. I think I am. No, it's all right. Okay. All right then. I will admit I'm not generally a super fan of installers like this. I'd rather use Homebrew or something like that, but we'll go for it for now. So
there is a PI in progress for that.
Sure there is. I'm going to, just to make a bit of space, I'm going to do some jiggering here. You just see that's still all viewable by people. Bearing in mind we're getting slightly cut off on the edge here. I think that needs to come in a bit. There we go. All right, that'll do. Okay, so that is installed, I think. Yep. Then move it into your path. Yeah, that'll double over. It's a bit harder to tidy up later, but we'll figure that out later. Future problem. Okay. All right. So install the prerequisites. So these are templates for projects, I guess. Rust, TypeScript, Python, TinyGo. I feel slightly most comfortable with TypeScript, so I'm going to go for that. Let's see, in the right folder. Okay, cool. Some languages. Now, this is nice so far. I'm going to pretend you're not here. Firstly, copies the line, even though you have a multi-line box here, which I really like. I also like the fact that as I click the tabs, it selects the right tab for the next section. And I will reiterate, this is not being sponsored. So if I say anything good, it's because I think it's good, not because. Because that time it didn't work. So there we go. Let's do it that way. There we go. Okay, J2 WASM. Is J2 WASM anything to do with you, or is that a standard WASM package?
It is. So it is a tool that, well, it's partly it helps get JavaScript compiled into WebAssembly, and part of it is tied to the Spin framework because it understands what a Spin application is. But it's built using, I think this one is built using Shopify's JV project, which helps with the JavaScript to Wasm compilation.
Now, this is actually interesting because we can see there's this template aspect here. A bit of me was already thinking, do I need to change into a directory somewhere? But it actually looks like, yeah, so you can see from this line here, I didn't clone a directory like you might normally do. It actually installed it into Spin's templates folder, wherever that may be. So it's working a little differently, which I quite like. It reminds me a little bit of things like Yeoman and stuff, which seem to have somewhat died a death. But yeah. So we have TypeScript and JavaScript. I have a slight preference generally with TypeScript, but I think for simplicity of getting started, we'll go with JavaScript so we don't have to deal with other issues. Okay. Enter a name. All right. Sure. I guess. Yeah. This command created it. Okay. All right. So the command created a directory. Did it? I don't see it. Oh no, I gave it a very unmemorable name. That's why it is there. Yes. Yes, it is. Oh, hang on. Something went weird there. What did I do there? Oops. That was odd. Okay, what's happening there? That's a bit strange. Let me see. Something's a bit odd there. What's going on there? LL is a real folder, yeah? Weird. Why? Why am I having problems changing into a folder?
Oh, there was a second. There was a second thing called LL, wasn't there?
I know.
Think the autocomplete
which
reveals
is
something.
Which is odd. Let's live demos. Yeah, I don't know what that is. I feel like I've accidentally used a folder name that has some special meaning that I'm not aware of. But anyway,
I can't help you there. I'm sorry.
LL. That's cool. I have no idea. So 3. There we go. Cool. All right. So now I'm going to open this up. I think in VS Code. Just why not? And we're going to have a walk through what's mentioned here. Create a directory with the necessary files needed to build and run a TypeScript Spin application. Change that directory and look at it. Yes. The additional spin.toml is the manifest, which tells Spin what events should trigger what components. So, I mean, I'm assuming it's going to be exactly the same, but let's have a quick look. It's got my name. It's got my email address from somewhere. I'm not entirely sure where. Don't know. Maybe from Git or something like that.
Yeah.
Trigger version, and then the various components, the WASM source, excluding node modules. That makes sense. Component triggers, component builds. Okay, all sort of makes sense. And it looks like this. I wasn't sure if this was a local route, but it looks like it's something more specific to Spin.
Yeah, it's specific to the fact that you have an HTTP triggered application, which basically means it's an HTTP endpoint. So that particular component is now mapped to a particular route.
So let's have a look at the code, and this is going to be the JavaScript code, I assume. This I think is slightly different because this is, I think, the TypeScript version. But yeah, actually it is quite different. That's quite different, actually. I think. Oh yeah, the JavaScript version looks slightly different. There we go. So a function with the same signature is what we're mostly interested in, I think, here. The Spin J2 Wasm plugin looks for the handle request function by name when building your application. All right. Let's do it then. People always ask me what that weird thing on my terminal is when it's not blocking me. It's called Fig. And I have profiled it before, and it seems to have become more reliable recently. So if you like the look of it, then take a look at it. Okay. Spin build. The moment of truth. That's Webpack first. Pre-initiating. Ran it.
Yeah, we can dive into that at one point.
Sure. Okay. Let's carry on for now.
Yeah.
I was interested. This is obviously TypeScript, which I guess is more efficient, or maybe it's less efficient, because mine is smaller by the looks of it, which is interesting.
There might be a discrepancy between versions from the doc screenshot and what you're running today.
I'm not really going to dig into analyzing that. And we saw the build command. That makes sense. I actually wonder, out of interest, though, it's going to be relatively simple. Well, what is the build command? The build command is npx webpack. Okay, so let's actually look at that in a little bit of detail. It's using this npx thing, which is nice because it just gets the dependency for you. Production mode, which I suppose makes sense for something like WASM, and then uses, so it's actually done doing all of it here, the output. So yeah, there was some custom syntax in that build command. Oh no, Webpack is there. Okay, so it's, must have been npx is one of these magic commands that just appeared in the past few years, and I'm not entirely sure what it does. It just seems to always work. So, okay. You can always spin build as a shortcut. Spin build as a shortcut. Spin build can be used to build all components. It's a flag. Run it. I like also the fact that at each point we're getting these for more details. My only comment, and this could be my monitor, because the monitor I use for the output to video has got some weird contrast. Some differentiation between these boxes might be useful, is all. I don't know. But then maybe they are, and I'm just not noticing because green has such poor contrast. We'll see.
Yeah.
So spin up. Okay. All right. Would I like to see? Is this even if I'm using JavaScript, the Rust log?
Yeah, Spin itself is built in Rust, so that's why.
Oh yeah, I just literally the text box beneath it says that. Hello from JS SDK. I mean, that doesn't seem particularly amazing, does it? But I get the impression that if we, firstly, that's. What I'm interested to see, I'm using Safari here, which may not be the best browser to check this, so I might quickly open up Chromium browser to test this better. I'm interested to see, because I think if we looked in the console or network or somewhere, we would find more clearly that this was a WASM application, yeah? Or not?
No, not in this case.
Not in this case, okay. So that, because the WASM file is running locally, and it just
the WASM file is running locally on your machine and basically just exposing an HTTP endpoint.
Yeah.
So we are sending HTTP back to you.
Okay. And so
you could send back a WASM file.
No, for sure. And this is where I suppose the cloud aspect comes in. The WASM file will be running on your cloud instead.
Yeah. So in the case where you run this locally, there are two processes that are being started when you do the spin up command. There is the spin host, which you can consider the equivalent of a web server, right? Mm-hmm. And that spin host opens up this endpoint and has the registry of the mapping between the HTTP path and the component that you build using JavaScript. Mm-hmm. But all that the host knows is that any request coming in on that route will be served by the WebAssembly module that was defined. Okay. So from that host process, it's just serving WebAssembly components or handing over HTTP requests to WebAssembly components, irregardless of what programming language you use to create those.
And just to actually let's for a moment let's switch back into just to clarify some things, and I think this is where the serverless part comes in.
Yes.
For those of us, including myself, who don't fully understand how WASM works. So this file, this WASM, it's a module, isn't it? I think
it's a WebAssembly module.
Isn't running, is it? It just gets invoked each time it's called. Is that true?
That is how we use WebAssembly modules in Spin.
And that's when the serverless aspect comes in. Is it's not sitting there just waiting. It does something when it's invoked, basically.
Correct.
Yep, and that's where it becomes serverless. Okay, cool. All right. So next steps. I'm wondering, what do I want to try next? Learning how to build your Spin application code sounds tempting, but also rather large. But let's have a look. So a Spin application is made up of one or more components, binary WASM modules. And I think I remember talking about this with Matt at KubeCon. This is sort of where the, I guess, serverless, micro-serverless, whatever you want to call it, comes into play, where different modules might return different, to respond to different calls for service, if that makes any sense whatsoever. Yeah. Okay. Okay. Because most compilers don't target WASM by default. By this, I suppose we mean the language compilers. So that's why there's that extra step in the JavaScript builder here. Special command options, which you may not have at your fingertips. So I suppose this is that instead of me having to go and download, and I honestly can't remember the names of a lot of them because the last time I looked at WASM in any great detail was a little while ago. If I wanted to go and download probably one of a multitude of JavaScript WASM compilers and Rust WASM compilers and Go WASM compilers, I'd have to figure them out. I'd have to figure out which one is best, whatever that means, et cetera, et cetera. And with Spin, you're taking an opinionated opinion on that for me.
Yeah, I mean, not necessarily on the compiler. We have in the case of JavaScript because that's...
because there was that additional dependency, yeah.
Yeah, we are using JV, right, as part of that. But if you were on a Rust toolchain, for instance, you would have to... You could just use the Rust WASM32 WASI target.
Yeah, it has it built in, doesn't it? Yeah.
And that's not specific to Spin.
And I think
so it depends on the language.
I think Go now has something by default as well.
Go got WASI support fairly recently and working on an update for SDK to also support Go and not just TinyGo. Okay.
Yeah, and I think this comes into the aspect, and this is where things become a little bit familiar with I guess, some other paradigms here. So this could be the equivalent of a very simple Kubernetes definition. This could be similar to a Docker Compose file, this aspect of components here. And then, this is obviously not a very good example, but I could have a second one there, et cetera, et cetera.
The easy way to do that would actually go back to your CLI, and then there's a command called spin add.
Okay.
And if you're in the directory where the spin.toml is, you can add additional components that way.
Okay. So spin add, I don't know, admin.
Yeah, you would have to define the template there. So it's the same as spin new, and then you can either choose a template or just name the template.
So I'm actually wondering. Okay. So
but you want to use spin add here.
Yeah.
As you already have one in there, you want to use spin add and not spin new again. You don't have to supply any additional arguments to spin add.
Okay. So if I do this, for example.
Yes.
Yeah. So, I mean, I'd say it's going to be, it's not obviously very helpful, but if we look, there we go. Yeah.
And then you want to, between line 13 and 21, you want to distinguish which component is serving what route in your URL structure, right?
Yeah. So I could say, hello. Is that correct? Because those three dots were slightly odd syntax, but
It's a wildcard syntax, yeah.
yeah, I've actually came across that recently, strangely, in a very different situation. I'd never come across that dot 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 syntax, and then I discovered it recently in a project called Astro, which is now what my website's built in, and it uses something similar in a different way. But I'd never even encountered it before. It was very strange. But I mean, this is the interesting thing here is what I'm just trying to understand here is, firstly, it's added a work dir, but we don't have a work dir here. What's the work dir?
So this is because so the sections you have underneath these components have different meanings in terms of sort of where in the what they refer to in terms of when you use spin. So everything on the component build is tied to running spin build or the act of compiling. In this case, when we added that extra component, we created a subdirectory called admin.
Yeah.
So what workdir refers to is that the command you have in line 23 will be run inside the directory called
yes,
admin.
and I could rearrange things if I wanted.
So you could start rearranging things if you wanted to, correct?
Let's make this a little bit different. I mean, again, this is not very complicated, but and is it always called handle request, or is that just this example?
I think for JavaScript and TypeScript, there's a dependency on that. I think we saw that in documentation before, because the way, and it ties into how we use Webpack here.
Yeah.
With Webpack, we create that one. We turn this into, I think they're called ES modules in the JavaScript world, right? Yeah. That has everything, and so we have that one single JavaScript file. Okay. We need a particular signature of that file for the Spin2JS plugin, because the Spin2JS plugin takes that one JavaScript file, and that's the one that's being compiled into WebAssembly.
Yeah.
So for JavaScript and TypeScript, we have that dependency. In other programming languages, you're more free to choose the function names. Yeah. There are other ways we annotate sort of the entry function. And
I'm assuming then, I'm going to just dive into this and just experiment and see if it works.
I'm as excited as you are.
I'm assuming I can just do that, and it should do it for both. Oops. Oh, I didn't do... now that's...
And that's a discussion point. Should we add npm install under the build command? No, well, first time it would be nice, but second time it would be not so nice. So
yeah. So it gets slightly... I think you could do something like this with, I don't know, JavaScript has a bunch of these workspace type things, but let's just... So hopefully that time. This time even. Yeah. Okay. And it was spin up. What's it? Yep.
Spin up.
Okay, and that's interesting as well. We can actually see the two different paths. I'm going to, again, especially for debugging, I just sometimes trust Chromium more. Hello from admin. Yes, and the other one is hello. Apparently, I don't actually. Yeah, there we go. Lovely. Is there any way to actually? We could do this with the Rust log, can't we? To go back to remind myself what that was. There we go. Let's see. Oh, yeah. There's a lot more. Let's see. Okay, yeah. So this is coming from... this is coming from the Rust code, yeah.
Yes.
If I wanted to get the JavaScript debug, I guess I just use conventional JavaScript debugging methods.
Yeah, so at runtime, we run these as WebAssembly. So we don't necessarily
That's
know
true.
that
True,
they came
actually,
from
that's a good
JavaScript,
point, yeah.
right?
That's a whole other probably conversation topic of how to.
Oh, it is, yes. And there are works in some of these languages around, breakpoint debugging and things like that. And then how do you get from WebAssembly back to JavaScript and all of those? It's not a very mature story that is today. Yeah. So usually what you will do is you will just print out to console and you will see that as you run your application.
Yeah. And we can see this is all just done for us by using that template. Yep, so all that. Application after build. Yep. Yep, we just talked about all of that. Yeah. Yep. Next steps. Try running your application locally. That's what we're already doing. I'm not sure what this tutorial thinks we're doing. That's what we're already doing. You're really pushing me to go to this cloud aspect. So before we do, let's just see
it is really easy, right? But
let's see if there's any other topics there. Writing applications, building, running applications. I don't know if there's any more we can cover. Application output. Okay, so it's all relatively simple so far. I think this is the interesting thing. Sometimes when you're a sort of lightweight orchestration tool that has a big dependency on lots of other projects, there's not so much for you to say,
No.
Publishing to registries. Okay. All right. Go on then. Let's try cloud. Okay, here we go. Got to get back to it now. Where were we? Okay. This is the big Fermyon cloud. Full spin. We did that. Login. I don't actually have an account yet, but let's set that up. Or, doesn't say I have to create an account yet, so let's just go for it.
Let's see what happens.
Let's move that over a little bit. Okay. And up a bit, sorry. Because I'm recording this in a slightly different way, all my usual places where I know things get cut off, it's not quite in the same place today. Copy your one-time, oh dear. Is that going to be? I guess so. We'll see. Oh, there we go. Okay. Nice. Oh, there we go. Cool. That was easy enough. Clone the quick start repo. Okay. Do that.
We already have an application, so we don't need that in this case, actually.
But maybe it's better.
Yeah. Well, I think it actually has confetti. So, if you want confetti, then yeah.
Okay. Oops, I'm seeing a not found, but that could just be because it's waiting, I suppose.
Oh, you still have the Rust trace lock on. You said that in your session, which is why you're getting a lot of interesting stuff.
Oh, there we go. Yeah, and then we have that there. I'm assuming that's it. So what am I seeing here? This is the JavaScript, or
This is the application you deployed that has both
so
the JavaScript and the TypeScript.
So it's running everything.
Yes.
Is there any way here to, if I go into my cloud, I can see this is the name of the overall application, I guess. Can I visualize the component somehow?
No, we haven't done that in a UI fashion yet. No.
So this is basically it for now. Yeah.
Yes.
So this is where things get interesting. I'm going to explain a use case to you, and you can tell me if this would work or not. Okay.
Yeah.
Say I have a Go application that I obviously probably need to do some re-architecting to get it to work within WASM. I can have that Go WASM, it's just a WASM, running in your cloud, and it will sit there responding to requests, basically, and pass back whatever I tell that code to, I suppose. Yeah. And this is where it's interesting, because I will show you something. The use case we've been trying to think about for some time is, let me show you here. So, so you can see these squiggly lines showing up here. This is this project that I work with a bit called Veil. It's an English language linter. And I actually maintain the VS Code extension, which is what's happening here. But the Veil itself is a Go binary. So for the VS Code module, you need to install it locally, and it's running locally, and I can also just trigger it there, and you can just approve the point.
Okay.
In the past, people were always asking, how can this run in, how can I use a similar tool in the browser, in Word, in whatever? And one of the major problems we always had is because by default, a lot of things will block applications running in on the command line. Depends on the platform. But so we've been thinking for ages of having like a service running somewhere that all these browser instances and things could connect to. And it's been sort of, and we've actually been thinking about, could we do it with WASM? So it returns a lot more information. It returns basically a lot of, I can actually show you. It returns, there's a readme isn't there. So basically for most of the tools that use the binary, you return JSON because then you can parse the JSON and do things with it. So it returns a lot of this sort of thing, basically.
Yeah.
So that's obviously can be sent across HTTP relatively easily. We've been thinking, could we do it with WASM so people don't have to install that dependency somewhere? So I guess the question I'm leading to is with Spin Cloud, what's the pricing?
What is the okay? That was so this is an open beta project still or service, and currently you run things for free. We allow you to run up till 5 applications, and there are some upper limits on requests. We hope to announce pricing very, very, very soon, so that you can get an idea of what you can continue to run from free, and when you will fall into a paid tier of that. Yeah,
and you probably will have a free tier of some description, I guess.
Yes,
we
will.
Yeah. Okay, that's interesting. Is it? I mean, sorry, carry on.
But for your use case here, right? And I think this is where, I hope. Well, I hope that what you experienced, at least, the getting started with creating the Spin application was fairly easy, right?
Yeah.
And the number of dependencies you needed to have a local experience where you can actually run things, and that was, there was very little stuff requirements wise.
Yeah.
And this is where we believe, WebAssembly, because it's a common compilation target across programming languages, it works really, really fast. The binary outputs are small, and there's stuff around security and things like that. It is just a very, very good foundation for, both great developer experiences, but also, orchestrating and running things in the cloud.
Yeah.
So I think the type of the service that we have is not necessarily, revolutionary, or, building a platform running applications like this is not, but the fact that we use WebAssembly just fixes a lot of problems that you usually see in these platforms.
Yeah.
Where things like cold starts, we don't have those problems because we just run WebAssembly. We don't run Python version something with a particular framework, even though that your application were written using Python, particular framework, because we just run the WebAssembly, right?
Yeah.
And it doesn't matter what you use as a programming language. It makes the operation story extremely easy in that sense. So even with an application like this, because no cold start, if usage is sometimes, or not consistent over time, things are not necessarily are incurred extra latency, if an infrequent request comes along. But on the other hand side, because whenever you ran even locally on your machine, the WebAssembly module wasn't loaded until a request came in.
Yeah.
So the execution or the handling of the request implies loading the module, handing over the request, handling the request, and unloading the module. So because that's normal operation, you don't have to think about scaling back things because they don't run unless requests are coming in.
Yeah.
So where you might have thought about, serverless is sort of event-driven and maybe ad hoc type of request patterns, then those lines are sort of started blurring with these technologies because there is no on or off. It's always whenever there's a request, we just serve it, right? Yeah.
I'm going to go to a couple of other quick things. Just going to jump back to showing them whilst I'm talking through them. There's a couple of things there that you said that reminded me of the conversation I had at KubeCon, and I think we're going through these extra pages of docs. We're going to come to some of them. Nothing's running, is it? No. Okay. All right. Let's just. So there is a VS Code extension. We can have a quick look to prove that. I can't imagine why. There it is, that one. Yeah. Yeah. So you can, there's a bunch of different things you can do there. It looks reasonably new-ish, I think. So there is a VS Code extension. But this is actually where I think we were getting to what we're talking about, and what I was talking about with Matt at KubeCon was that you have these services running, but of course, probably for any application that you want to have, these services need to talk to each other as well. And we can see examples here around Redis and Postgres. And this is something that is, if you use Kubernetes, if you use Docker Compose, which you don't usually use in production, but you get the point. There's they have their patterns as well for allowing that to happen. And it was often one of those things that was the most complicated thing when all those projects started. So let's have a quick look. How do you do it? I mean, we could run this and have a quick look, but behind the scenes, are you using something standard within WASM, or are you using something that's unique to Spin? What are you using to allow these services to talk to each other?
So if you build something that's based on HTTP as the trigger pattern, which is the one that you created earlier, you can basically call with HTTP between your services. So
it is just that, but yeah.
That's one way of doing it. If you want to, have it backed by a store, where things are being read and things are being written, then Spin has a built-in key value store.
Yes, that was what I remember speaking with Matt about.
Yes.
I'm not seeing
that works
anywhere
both
yet.
locally. I think you might need to go to, let me check where that is. So on the documentation side, if you do Command K, you can actually search. And then if you type in key value, I'm pretty sure you will find key value store in
For some strange reason, I can't seem to.
Just try and type. I think there might be a UI bug that we discovered earlier this morning that's not showing you.
This could be a Safari thing again. Let's see.
Just start typing here.
Okay.
And then if you do key, I think just key value or something like that.
Key value.
So you get the key value store,
Where was that hiding? It was just, there it is, API guides, okay. Okay. So this is inbuilt, but if I wanted to talk to, so let's just very quickly talk about this. This is an inbuilt key value tutorial, and from memory, basically you use the SDK, so it does require some recoding, but it's relatively straightforward to use without having to have additional services, I guess.
Yeah, what we do locally is so because the execution pattern is that these modules are loaded and unloaded on each request, the core model is stateless, right? You don't have memory you can share between requests.
Yeah.
Which is where the key value store comes in, because then you can easily buy it. You can see the API here is basically you open a store, you set a key, and you can then obviously do store.get or store.key or get keys or exist or whatever. What we do in the local experience that you have on your machine is we we create a SQLite instance as a file.
Yep, for sure.
So things will be persisted between requests and even between running spin up and new builds.
Yep.
And then if you go, so the key value interface that you have here is backed by a provider that you define.
Okay.
And you can add in other types of providers. We have a provider for Redis.
Yep.
So instead of using the SQLite implementation, you could use Redis instead.
Yeah.
If you go into the Fermyon cloud, we have an implementation there that is just available.
Yeah. That's cool.
And we are experimenting with other type of backing storage for that.
This is relational. You're not telling me you have... Oh, yeah, okay, yeah. It starts to get a bit weird if you were doing WASM MySQL. I don't think that's even possible, but that would be weird. Yeah, and we could see lots of other things here. Where was I looking? Around... No. They're creating the templates yourself, for example. Also the language guide. I was very quickly interested just to see what's in there. I can't imagine there's... it's basically constructing your application. There's not really any specific things you need to do in your code. It's just specific... Oh, maybe... Oh, no, there are some SDK. I don't think I really picked up on that whilst we were building that. This is from the SDK. So you do need to do some re-architecting. But it's relatively straightforward. And if I look at this and see, if I'd made an Express application, it's not massively different. It's returning JSON, basically. It's not hugely different. Okay. All right, we're sort of running low on time. It's pretty easy to get started, and we can see other things here, including this rather intriguing rabbit hole here. Yeah. Ooh, hello. This might be interesting. Okay, and a whole bunch of other aspects here. So let's... Fermyon, you have the cloud, you have Spin. Is there anything else? Is the Bartholomew thing, is that just kind of like a side project, quote unquote? Is Spin and the cloud the main things people should look at?
Oh yeah, and definitely start with Spin and clouds, because we consider Spin the application framework, right?
Yeah.
Cloud is a hosting option. Kubernetes is another hosting option, as you discovered in the documentation.
Yeah.
It's actually through a project in Containerd.
Yes. Okay.
So called RunWasi.
Yep.
So there are various. RunWasi supports other type of WebAssembly frameworks as well, not just Spin, but also just WebAssembly without an application model like Spin, for instance. So Kubernetes are deployment options, and then Fermyon Cloud, and then we built the Fermyon platform as well, which we're considering turning that into a reference architecture if you want to construct your own sort of platform that is not necessarily Kubernetes. The question is, how many people want to go down that route necessarily? But it's an opportunity. Then the main background story there is our cloud is not built using Kubernetes because at the point where we started that project, Kubernetes support for WebAssembly was pretty hard. For the scenario we have, it doesn't lend itself very well, which is why it's based on Nomad and some other pieces.
And there are now other options as well. And there's other competitors in this space, and some of them do use Kubernetes, and some of them have different things. And yeah. Okay. So we obviously saw there is a free tier because I was messing around with that with no problem whatsoever. You can also run it locally. I'm not entirely sure why you'd want to, but you can.
The good thing about WebAssembly is that it's platform, operating system and processing architecture agnostic, right?
Is it really processing architecture agnostic? But you have to build it, of course. So
no, not in the world of WASI. You don't.
Huh.
So the conversion from that WebAssembly binary format into the native code that's been executed
happens in the browser.
Well, it happens as a just-in-time compilation when you run it. So when you run the WebAssembly modules you run, we need a WebAssembly runtime in there. This is where we create the virtual machines that I mentioned early on. Okay. that WebAssembly runtime is called WassmTime.
I should have probably
And
dug into.
that is built into. Well, we can open up the machine if you want to do a follow-up session.
I could have like, opened up Activity Monitor or something and to see what was happening. You know.
Well, it's built into Spin, so you won't see that. We basically use WassmTime as a crate inside of Spin. But that's how we create a virtual machine that the WebAssembly module then runs in. And not until you actually run the WebAssembly module is it being compiled to run natively on the current operating system and processing architecture.
I actually kind of like messing around with virtual machines. So one of the interesting developments in most recent versions of macOS is you can now run Linux virtual machines if they're ARM native.
The demo I usually do here is I use a project called Lima, which is a way to easily create these virtual machines. So I have a Lima running Ubuntu on an x64 emulation on my Mac. So I build my WebAssembly ones and I run the same WebAssembly across.
So I've used UTM, which does QEMU. I mean, you can run x86 Ubuntu, but it runs extremely slowly. But
it is slow, but that's a nice demo to show this. It actually works pretty well.
The ARM versions of like Fedora or something are fantastic. Anyway, we're getting into digression here, but I actually kind of like messing around with this kind of stuff. I have no practical purpose for it, but I like messing around with it.
Oh, yeah.
If you enjoy what you're seeing here, which was pseudo live, you can subscribe, leave a comment. I won't say leave a comment live because this wasn't live, but you can leave a comment post. And for all those people who are waiting for the live experience, I do apologize. It feels live anyway, probably. And if you want to know more about me, you can look at christianschiller.com. Mikkel, I should probably give you an opportunity to plug. You obviously work for Fermyon, which got a fair bit of plugging. But what about you? Is there anything in particular about you you'd like to plug?
No, thanks for the opportunity. My role at Fermyon is I lead our developer relationships and product division, and
so you're the person to speak to.
Yeah, like a lot of the rest of the team, we have many years of experience in cloud computing, and the founding team originated from Microsoft, where I also spent many years building developer experiences and building cloud services. So there's a lot of baggage in this.
I think we could have some behind the scenes talk about this in a moment. Let's come off recording first. But thank you very much for joining me, and for everybody who watched later, thank you very much for joining me. And this will go out almost live, but it's an hour later. So I'll be back next week. No public holidays, nothing happening. So I'll have 3 videos next week. Watch out on my website or the YouTube channel for the schedule when I have decided it. And thanks for joining me, and take care, everybody. Goodbye.